about router protocol and everything. And just second, we'll be having an overview about router protocol. Third, we'll be exploring how anyone can integrate router protocol seamlessly in any of the dApps you are building on Oasis protocol. Fourthly, we'll be talking about some of the practical use cases as William just did. And lastly, we'll be having a Q&A based upon if anyone is having any queries. So we'll be just taking them up. So moving on with the introduction, talking about what router protocol is. So router protocol basically is a cross-chain layer 1 liquidity aggregator. It's a layer 1 blockchain which basically enables chain abstraction. You can build a dApp on router protocol and it can just easily go cross-chain in any ecosystem. We have different three products. I'll be just covering them up in a while. A quick overview. We have Router Nitro. It's a cross-chain asset transfer bridge. We have connected more than 30 plus blockchains, both EVM and non-EVM chains. Router Nitro is a really fast and really secure bridge, which enables you to easily swap or bridge your tokens from one chain to another. Talking about Router CCIF, Router CCIF is based upon cross-chain intents. Router CCIF basically stands for Router Cross-Chain Intent Framework. It's a basically plug-and-play infra for cross-chain functionality, basically simplifying the user experience in Web3. Right now, we have so many chains, EVM, non-EVM, we have so many wallets of every chain. So in order to simplify something like that, we have Router CCIF. We have some of our most major and most famous use intents by audiences of ours, like Stakestone adapter. And there are many more adapters like Arendrome and different adapters which we have built. So yeah, you can just try one of them as well. Now talking about Router Chain. So Router Chain is basically a layer 1 blockchain built upon the Tendermint's BFT algorithm. And it's a proof of stake layer 1 blockchain, right? Based upon Cosmos SDK. It's built using the Cosmos SDKs. And the major advantage of Router Chain, or the major factor why anyone should build upon Router Chain, is basically if they build on Router Chain, they can easily make their dApp cross-chain or omni-chain. And it's a really simple process, right? And you can just directly make your dApp compatible with different ecosystems, different EVM and non-EVM chains, thereby attracting different users, many users, as well as liquidity across multiple chains. So talking about some of the statistics of Router Chain, we have more than 1 billion of volume. We have $1 million of worth more than transactions, as well as the average block time for Router Chain is 3 seconds. More than 300 users have been connected on a chain on a platform, and we have more than 30 plus ecosystems as well as 100 plus partners. Now talking about how anyone can build on Router protocol as well as Oasis. So we'll be having a quick demonstration using the smart contracts. I'll be explaining the smart contract of Router protocol. It's a very simple smart contract. For this particular demonstration, we'll be taking up two chains, Oasis and Arbitrum. How you can seamlessly deploy a smart contract using Remix IDE on Arbitrum and then on Oasis Sapphire testnet. And then using a simple UI which you can create, we'll be just learning how anyone can integrate that particular smart contract, deployed smart contracts, contract addresses, and ABI, and how anyone can integrate it in any of the existing user interface. So yeah, I'll just go to my Remix IDE. Here I have my simple contract. I'll just zoom it a bit. Cool. So as you can see, I have two smart contracts here, Arbitrum ARB underscore pingpong.sol as well as Oasis underscore pingpong.sol. So first of all, I'll just quickly give you an overview of both the contracts, how everything is happening, how everything is going. And yeah, then we'll be just deploying it. Now, talking about, first of all, this line, basically it's import statement. We are using Router Protocol's EVM gateway library to get all the contracts, and we are basically using igateway.sol contract, which is very useful for triggering the gateway contract of every chain. So what this particular smart contract, pingpong.sol contract, is doing is, it is a cross-chain ping-pong smart contract, a really simple one, which is basically demonstrating how anyone can use crosstalk library to make a cross-chain message request, right? Crosstalk library is a library built by the router team, which is essential for communicating across different chains, basically making any cross-chain transaction. Cool. So basically, we have a contract function here. After that, we define the public keyword owner as well as current request ID. Then we are creating a map. We are creating a simple map, okay, of ping from source and acknowledge from destination. So what happens in a router chain? What happens is we have a chain A, we have a chain B, and on every chain we have a gateway contract deployed. So gateway contract interacts with that particular chain. It sends. Let's say I have a gate. I am on Arbitrum currently, right? And I want to go to Oasis Sapphire testnet, right? So on Arbitrum, I have my contract written. My contract will be directly interacting with the iGateway contract of Arbitrum, which is basically written by router team and is deployed on Arbitrum. I'll be sending my metadata to that particular gateway contract on Arbitrum, and that will be directly going to the another gateway contract on Oasis Sapphire testnet, which is obviously deployed by the router team, and it will be directly interacting with the contract which I wrote on Oasis Sapphire testnet. Cool. So this is again a small instance which I have created of router's gateway contract. I'll just zoom in a bit more so that it's more clear. Cool. So again, we have defined a custom error here. It's a simple custom error. And now we have defined few events here, couple of events. This event, ping from source, basically ping and pong, these are two words. Ping basically we use when we are sending a message, when we are emitting an event basically from ping from our source chain to the destination chain, right? It is being pinged on source chain and pong is being happening on the destination chain, right? So ping from source basically means we are pinging our source chain. We have entered our source chain ID as well as our request ID and the message which we want to send. Cool. And new ping is another simple event which we have created. Execution status and acknowledge from destination. Oh, cool. So these are the two variables which we have defined here. What happens is every time, as I explained the concept of gateway contracts, let's say I just sent a cross-chain transaction from Arbitrum to Oasis Sapphire testnet, right? What would happen is when the message would go to Oasis chain, it would give me an acknowledgement back. Okay, the message has received at Oasis destination chain, and now it will just give me an acknowledgement or revert back. You can say that yeah, message has arrived here. So for that, we have created this particular acknowledge from destination chain event. The two parameters here are simply a request ID as well as an acknowledge message. Now we have a constructor. Constructor is basically every time we deploy this contract, and whenever the contract is run, the first function or the first thing which runs in a contract is the constructor function. Here we have two addresses, a gateway address and a fee pair address. Cool. So I'll explain what these two are. Fee pair address is basically the wallet address of your MetaMask or any wallet which you are using, with which you will be performing all the transactions, right? And talking about gateway address, so gateway addresses are the addresses which have been deployed by router chain, which has been deployed by the router team, and they basically interact with the contract which you wrote on a particular chain on the source chain or destination chain, right? If I go to docs.routerprotocol.com, under that go to network section, and under that just go to supported chains. Here we have all the gateway contract addresses and different addresses which you will be needing while building a dApp. So just if you're on testnet, like right now, we'll be doing everything on testnet. So just go to the testnet option and you will be seeing all the gateway contract addresses which we'll be requiring in this particular demonstration. Cool. So like right now, we will be using two addresses, Arbitrum Sepolia testnet, as well as we'll be using Oasis testnet. Cool. This is the Oasis Sapphire testnet. And yeah, we have mentioned all the chain ID, chain name, and gateway addresses you will be needing. So yeah. And yeah, this is just the constructor function. Again, another function which we have created is set dApp metadata. This function is basically used to set the fee pair address on the router chain. Like every time your contract is, whenever you deploy a contract, it sends the metadata to the router chain, right? So as you deploy your contract, it just gives an assurance, okay, that here is your fee pay address, and using your fee pay address, you give the permission to router chain that you will be paying for this particular transaction. Cool. So as you can see in the parameters, we have used fee pair address, and we have defined some of the checks here, and we just enter and approve our metadata. Cool. Now talking about the another function, function set gateway. It's another really simple simple function. We basically set our contract to the router chain gateway contract, and in the parameters we have defined a gateway parameter. It is basically the address of the gateway contract which has been deployed on router chain. Now talking about a really important function, as you can see here. Yeah, the function ping. So function ping is basically used to generate a cross-chain request which pings the destination chain contract. As I explained above, we have ping and pong. Ping pings the destination chain contract. And if I talk about some of the parameters which we have used here, we have 4 parameters: destination chain ID, destination chain contract address, the string. Basically, you can define it by yourself, any message which you want to ping on the destination chain ID, as well as the request metadata, the basically metadata which we learned about in this function. Now we have simply sent a packet. Okay, what happens is on the source chain, this packet is encoded, and as it goes to the destination chain, it gets decoded. And using the isend function, we basically send it, basically isend method. It sends it from the source chain to the destination chain in the function iping. And yeah, again, we have some parameters: string, which is the custom string, custom message, basically you can define, and the destination chain ID, request metadata, and request packets, all the parameters which we defined previously. And yeah, function get request metadata, a really simple message, really simple function, as you can assume from the name itself. It is a function which is basically used to retrieve or get the request metadata, which is used while you have initiated your cross-chain request. And again, it takes some of the parameters: destination chain gas limit, the gas price, acknowledgements, gas limit and gas price, as well as the relay fee acknowledgement type, and is the boolean which we using here. And yeah, as you see, we have a method here being used, encode packet. So it's a method basically which when you receive the metadata, so along with that you receive this encoded packet, and it retrieves all the data collectively inside it, the data which is present in it. And yeah, again, another function, a really important function after iping is iReceive. This function basically handles the cross-chain request which you have received from any particular chain, right? It basically consists of 2 parameters, I'd say, packet and source chain ID. Packet is basically you can consider it as a payload, okay? As we just saw in previous functions, it's just the data which is sent by the source chain to the destination chain when it was just deployed, or you can say it was written, right? And source chain ID is basically the simple source chain ID of your contract. And yeah, again, we are triggering some of the checks here, and we are just sending our packet and encoding it. We have some custom errors here, and the function which we created above, the event which we created above, ping from source, we will be emitting it here because we ping from source. As you can see, I'll just scroll it a bit above. Yeah, ping from source is basically used when you create an event and when it is emitted, when your data is pinged to the destination chain. So here iReceive function, in the iReceive function, our data is being received on the destination chain. It is being pinged. So we can just emit our event here. Now talking about another really important function, iAcknowledge or ICK, which we defined it here. This function, it basically comprises of the acknowledgement, which basically tells, okay, now your message, your transaction has been received on the destination chain, and we are sending an acknowledgement that yeah, it has been received, and that acknowledgement goes to the source chain. So yeah, that's a simple acknowledgement. It consists of three parameters: request identifier and execute data and execute flag. Execute data basically returns the data from handle request from source function which we receive. And yeah, request identifier basically identifies the request, okay, that if the request is right, it's correct or not. So yeah, again, the package, the encoding we did in our iping function, as you can see. Yeah, here we did some of the encoding for our packets which we created, including the destination chain contract and the packet which we defined here. The encoding which we did, now we'll be just decoding it in order for the verification and the confirmation that yeah, we have received the call. So yeah, we'll be doing some of the decoding here, as well as acknowledgement from destination chain via a simple function, and both the events which we created above initially in our contract for execution status and acknowledgement from destination, we'll be just emitting those events. As you can see, these were the events which we created. They are really essential for the acknowledgement that yeah, we have received our ping, our message, our cross-chain message, and yeah, it's just confirmed there. Now, in order to interact with these cross-chain contracts, basically to make any of your existing dApps cross-chain, you will have to deploy these contracts on the chain which you want to, right? So for in this particular demonstration, we'll be just using Oasis chain, of course, and Arbitrum chain, and we'll be deploying our contracts there. We'll be getting the contract addresses as well as the ABI. You can follow the similar way, and later on you can implement it in any particular UI or a dApp you're building. So I'll just quickly go to, I already have injected my MetaMask here, and my account is just reflecting here. And this is my Oasis pingpong.sol contract. So just go to the deploy section under deploy and run transactions. You will be getting two values to enter: gateway address and fee pay address, right? So just go to this particular URL, docs.autoprotocol.com/networks/supported-chains. You will be able to see all the contract addresses. So here, contract was Oasis, right? So I'll just take my Oasis contract here. I'll be entering it here. Now in the fee pay address, I'll be basically needing the contract, the wallet address using which I'll be approving this particular transaction to route a chain. So I'll go to my MetaMask wallet. Okay, here is my account. I'll just switch my network to Oasis Sapphire testnet. It is reflected in my Remix injected MetaMask provider as well. As you can see, the chain ID for Oasis Sapphire testnet is 23295, and it has been implemented here. I'll just simply copy my wallet address and enter it here, and I'll click on deploy. So it will just prompt my MetaMask wallet, and I'll confirm the transaction, and it will be deployed here. We'll just probably wait for a couple of seconds. Meanwhile, you can also see, like previously, this is my Arbitrum chains contract address which I had deployed. It's just the same contract. Depending upon which chain you are interacting with, you would have to use the gateway contract addresses and integrate it. Like right now, we are interacting with Arbitrum and Oasis testnet, so you would have to use that. And this is previously the Arbitrum transaction I did. Here is the contract address which I had got. I'll probably zoom it a bit. Cool, I guess it would be visible now. Yeah, so this is the contract address which I had got earlier. And this is the from address, which is basically the fee pair address, or you can say my wallet address, which with which I approved the transaction. And yeah, okay, the creation of ping pong is still happening. Probably there's some internet connection at my place. Also, just make sure to go to testnet.routerscan.io/transactions. What happens is, as we approve the fee pair address, right? For fee pair address, as I explained, fee pair address basically means that, okay, this is the wallet address of my wallet with which I'll be approving all the transactions. So make sure when you approve all the transactions, you are having some route tokens in your testnet. As you can see, I have 27 roughly route tokens here. So make sure just go to connect wallet on the above URL. This. Okay, there's some issue happening here. Give me a second. Yeah. Go to testnet.routerscan.io/feepair. Click on connect wallet, browser wallet, and my MetaMask wallet is connected here. As you can see, previously I was interacting with the Arbitrum Sepolia. So here I need to approve this particular transaction that basically I'm approving it to router chain, that my fee pair would be interacting with router chain and the fee for route tokens would be deducted from here. So I'll just click on approve. And you can see that here the transaction would be approved. And yeah, you can see the transaction hash. I've received a transaction hash here and it shows that transaction is completed. I'll just refresh it a bit. And yeah, you can see everything is just completed here. So I'll just go back to the remix ID and yeah, I guess there's some issue right now. But yeah, this is how basically you interact with a contract. Again, here's my Arbitrum ping pong contract address. This is the same contract which we wrote. And if you want to see its deployment, I'll just quickly go to the chain gateway contract addresses. I'll just copy Arbitrum Sepolia contract address, paste it here, and I'll be entering my okay, this is not Arbitrum. Yeah, here's my Arbitrum Sepolia contract address. I'll just put it here, and yeah, I have injected my MetaMask and everything is just connected. I'll click on deploy, and similarly, it would be also just deployed. And yeah, now going back. So here is Router Academy. You can also view our Academy here. Just go to academy.routerprotocol.com. It's basically a resource hub which you can utilize for building or integrating router protocol in any of your dApps. Just go to Learn Now section and you will be directed to entire courses page. Of course, it's all open source. And just go to any of the course. Like right now, we'll be going to building on router chain course. We have all the resources you will be needing. Like right here, we have built a tic-tac-toe contract on router chain. So you can learn about it, how the integrations happen. If I talk about Cosmos, EVM, so any ecosystem which you are building in, like right now in Oasis you're building, so you will be needing how to interact with EVM side of the router chain, right? So for that, just go to these particular courses, these documentation, and yeah, you can just refer them up. And lastly, talking about some of the use cases and some quick ideas which you can build. Of course, there are many more, but here are some really simple ideas which you can use. First of all, a cross-chain confidential voting dApp, a simple confidential voting dApp which you can create using Oasis Sapphire. You can implement the Oasis privacy layer, as well as you can integrate router chain to display the results of the voting dApp in any other L2 or any other chain like Arbitrum, Avalanche, etc. Similarly, you can build an auction betting dApp of NFTs. You can it and it can be cross-chain. The NFTs, everything would be have hosted privately, and the cross-chain part of bidding would be public, so that anyone can just view it. And yeah, again, we have a simple implementation of cross-chain, confidential cross-chain quiz dApp, a simple dApp which you can customizely create your own polls and quizzes, and anyone can just reply to them. And again, the results are displayed on some any other chain, probably an omni chain, with the help of router protocol, of course. So yeah, that's a really simple demonstration of how you can utilize router protocol and how you can integrate the contract side of it in any of our existing dApps.